Alright, here's some help with simplifying basic rational expressions. So not dealing with any equations, we're not graphing anything, let's just simplify them into their lowest forms. So let's take a look at the first column. We have 10r plus 20 divided by 40. Not really a rational expression, it just happened to be a fraction, so let's deal with some fractions to begin with. Let's take a look at the numerator and let's divide out a 10 or factor that, and the denominator stays the same at 40. What we can do now is, now that we factored out the 10, is reduce the 10 with the 40. Divide both of them by 10, they're both divisible by 10, and reduce that to 1 and 4. So in the end, this is simplified by writing it as r plus 2 over 4. Okay, so now let's apply that to a rational expression. So second column, we have n squared minus 2n minus 24, and we have n plus 4. Nothing is equivalent yet, so we cannot cancel anything. So what we can do is let's factor it down. Let's look at the basic ingredients of each piece. The denominator, well actually step one, let's take a look. Our denominator has a variable in it, so we don't want that to equal 0. So we set that equal to 0, or not equal to 0 in this case. Subtract 4's, and we don't want our n to be equal to, our n cannot be equal to negative 4. So that is our excluded value. Cannot have negative 4 as a value of one of our inputs. Otherwise, if you divide by 0, it will become undefined. So that's where, if we needed to graph, we would draw the asymptote and draw a dotted line. So again, it's also called the asymptote. Next part is, let's take a look at what we have. Go back to n squared minus 2n minus 24, and let's factor it. And so this, the numerator, becomes this, n minus 6 over n plus 4. What we need to do is treat them as blocks or pieces. So n squared minus 2n minus 24 is one big piece, and we now divide it into two smaller pieces, or factor in two smaller pieces. Now we have n plus 4 over n plus 4. I'm going to put parentheses around each of them to show that those are entire pieces. N plus 4 over n plus 4 we now can cancel, because if we have those two divided, it would just become 1. N plus 4 divided by n plus 4 is 1. So what we have left is, we have n minus 6, and n not being equal to negative 4. That would be our simplified form of this expression, as well as we have its excluded value. So n minus 6, and n cannot be equal to negative 4. Okay, let's take a look at the third column, where we have more complicated expressions, or polynomials. Numerator, let's divide out a 2x, because 2 and x are in all three terms. And we get 2x times parentheses x squared plus 6x minus 27. The denominator factors out cleanly too, to be x plus 9 and x minus 8. Let's look for our excluded values. X cannot be negative 9, otherwise that would become 0. X plus 9 would become 0. X also cannot be 8, otherwise, 8 minus 8 would give you 0 as well, and you'd have another undefined scenario. So this actually has two asymptotes, or two excluded values. If you had to graph this, you would draw two dotted lines. Let's go back to the numerator. Oops. Let's factor that out. Bam. We get 2x times x plus 9 times x minus 3. Denominator stays the same, x plus 9 times x minus 8. We can recognize that we have x plus 9 in both the denominator and numerator, which we then cancel. That leaves us with 2x times x minus 3 over x minus 8, with an excluded values of negative 9 and 8. That is in a simplified form, and it expresses its excluded values. Alright, thank you very much.